In this video, we are going to look at the graphs of three different power functions. We know that these are power functions because in all of them, there is an exponent and the exponent is known. So our power functions have a known exponent. I'm going to turn to my graphing calculator for help with the graphs. And so I'm starting off with the y equals 16x squared, and it gives me a window to use as well. So in my graphing calculator, you see I'm in the y equals. You see that my plots are all turned off. If you need to do that, arrow up to your plot and hit enter to turn it off. I'm typing 16x squared, and then I'm changing my window as I was instructed. So the x is to go from 0 to 10, and the y is to go from 0 to 2000. And I will graph. And I see a concave up curve. I see something that truly looks like it would be an exponential curve, even though I did not type an exponential formula. And so I'm going to go back to my slide and just draw a sketch of what we see going on here. So our x-axis was 0 to 10. Our y-axis was 0 to 2000. And we saw a curve. And we said it was concave up. And I also noticed that it is increasing. I could describe the rate, but I'm not going to. I'm just going to keep with a very basic description until I have a chance to look at other graphs to know what is or what is not important. So the second graph that I'm supposed to create is y equals 350x to the negative 3. And again, it gives me the window. So going to my calculator to the y equals, we had 350x to the negative 3. And then in my window, I again was having x 0 to 10, and my y this time was 0 to 50. And so I see a curve. Again, it is concave up. This time it is decreasing. Again, it really looks like an exponential curve to me, even though my equation was a power function and not an exponential equation. And so I'll sketch this out. This time we went 0 to 10 in the x direction, 0 to 50 in the y direction, and we had curve something of this nature. We noted it was concave up. We noted that it was decreasing. And so we have our third one. This time we have 15x to the 0.3 power, and we have the exact same window for this one. So back to my calculator, y equals 15. Let me clear and start over. 15x to the 0.3 power. Window was the same, so the 0 to 10, 0 to 50, and then I'll take a look at the graph. Oh, wow, totally different graph. So this graph is concave down and would look almost like a logarithmic function. So I'll take a moment to come here and draw this. So again, x-axis 0 to 10, y-axis is 0 to 50, and our graph was concave down curve. However, I do note that it is increasing. So it's at a decreasing rate, but it is increasing. It is going uphill just very slowly as it moves along. So I'm asked to make some conclusions about the graph. And so what I have seen so far is that there is variety of shapes. Specifically, it could be concave up or down. It could be increasing or decreasing. And so because of this variety of shapes, it does not have an iconic shape. So exponential had an iconic shape of concave up. Logarithmic had an iconic shape of concave down. Logistic had the iconic S shape. And power functions do not have an iconic shape. They have a variety of shapes. And so we cannot just look at a graph and know that it is a power function. We have to have additional information to determine that it is a power function. Now, there is a connection between the known power or the known exponent and the graph. So this first graph where it's concave up and increasing, this would go with positive exponents. Specifically, exponents greater than 1. Our next one, this concave up but decreasing graph, this goes always with our negative exponents. And finally, this last one, this concave down but increasing, this goes with our decimal exponents. So that may lead you to the question, well, what if I had a negative decimal? And that's a good question, and it led me there as well. If you have a negative decimal, you will still get the concave up decreasing shape. So that negative is going to override the decimal part of it. But if you have a decimal that is positive, so these exponents that are between 0 and 1 but positive, that is going to lead you to the concave down increasing shape. So the known power in the power function really does control the graph, but because we can have a variety of exponents, we can have a variety of shapes.